it's not.
Is there a GUI with that installation as
It's
well?
weird because I didn't do a full installation.
Chris, is there a GUI with that installation as well? Is there a GUI with that installation as well?
Yeah.
Or is it all combined?
It's I flashed it properly.
It's just there's many different things. You need Python, you need Node.js, which is actually like 4 gigabyte or something. You need, and then the Edge CLI itself, which is a command line thing. So it's not actually that hard. It's just that it can get hard if your computer.
No, but that's, is there a GUI?
No.
So that's okay. It's all combined.
Yeah.
Oh, so you're saying that because I didn't think, I thought I did the full thing, and I was just did the CLI thing. On my Mac.
But it's the Edge Impulse CLI.
Yeah.
Yeah, but probably you already had Python and Node.js installed. You just went ahead and installed this CLI.
In order to install CLI, you're saying you need to have Node.js and so on?
Yeah, and Python. That's what they say on the website.
No, that's not true.
Maybe we don't.
In fact, I did not have Node.js. I installed that CLI and it worked. So just install the CLI.
Sorry, everyone on the call. We're trying to sort out a few
What is the CLI thing?
little things. Where's that one?
Yeah, so when you click on that one.
So this one's done. This one goes here. All right. That's better. Okay. Let's see now. Where's that? And where am I? I can't see myself. There we go. No.
Oh, okay, here. Yeah.
Okay. One minute. Almost there. There we go. Okay.
It's just, as far as the you're just running your CLI and then flashing the code properly.
Everything like that, because I did this like 2 months ago. I don't know what I did, but I remember.
All right. So shall we introduce everyone a little bit and say what's going on? So can everyone at home hear me? Or in school? Everyone can hear me very good. Can see me. Can I hear you? That was the thing. There was one more thing I need to do. Okay, I can hear you, but it's pretty weak.
Okay, I'm saying something.
Yes, I can hear you very well, actually, so maybe I don't need this.
Awesome, okay.
Let me just give it one last try. Here we go. Okay, can you say something again?
Hello?
Hello, Chris.
It's still from
Hello?
the thing. I'm gonna switch to... There it is. No, headphones, no. Yes. All right, say something one more time.
Test? Hello?
That's it. Excellent, thank you. All right, so now we can hear you properly, and you can hear me, you can see me, good. So, right, so yesterday we had a kind of an introduction to AI generally, and then we got started with the TinyML and generally with the Edge Impulse system. And the thing we're going to do today is to just slowly, step by step through a couple of exercises, starting with an accelerometer exercise. And we're going to try to go from kind of start to finish and actually upload something to to the Arduino, and then tomorrow Stanislav is going to give you a bit more detail about how to kind of edit the other Arduino sketches to kind of customize things a bit more. So the way we did it yesterday was we used a kind of quick installation. There's something called Web USB, which allows you to just to access this little microcontroller, the nano microcontroller, or any other kind of COM port connected controller from without having to install anything else. So you didn't have to install Python, you didn't have to install Node.js, didn't have to install the Edge Impulse hardware. And that worked for most people in our class, but there's a few that were having trouble on Macs, which is part of the learning thing. So we're writing down the bug, documenting it, and we're going to overcome it. But if one of you wants a different computer, we have several here. Alternatively, and if anyone at home was having problems, you need to go through the full installation. So the document that I shared yesterday, which I'll pull back up, I'm going to continue editing that and just making sure that it covers everything, including bugs and kind of weirdnesses on different systems. But I will post it in the chat here. So this is the kind of shared document that I'll edit so that everyone who comes into this later or maybe the next year, we can start from this document and kind of get started quickly. So there was the quick installation there, which worked for most people. So you two was it working for you now?
So sometimes it works and sometimes it shuts down. Like I was able to get 2 pieces of data,
Yeah.
accelerometer,
Okay.
and then otherwise it just shuts my phone down.
Interesting.
Mine fails to connect.
That's
Yeah,
amazing.
I think, so Christian, I must have installed this.
Okay.
I didn't realize.
Yeah.
Sorry, man.
No, but so do we want to just step through the full installation?
That's what I did.
Okay, so maybe we do that. And I will share my screen and I'll show everyone just exactly what we're doing. If you want to follow along, you can do that too. So let me share my screen. Screen 2. All right. Okay, so all right, so this is the document that we were starting from, that I just shared in the chat. There is a link here to docs.edgeimpulse.com, which is where I actually got all the instructions that we're gonna follow here. So let's just go over to this one, and I'll share this in the chat as well. Well, you have it. But so I'm gonna work on this one, and we're just gonna step through everything and make sure everyone's up to date. So first of all, I scroll down to Edge Impulse CLI, and you have the installation instructions here. So you need Python, first of all. So I'm going to right-click on that, open up Python, click on download Python. It's going to take a little while. All the steps are written down. If you've done this, you can proceed if you want, but I'm just going to step through this slowly. If anyone wants me to slow down, or you're having a problem that I'm not seeing, just let me know.
You installed Python like 5 times.
Yeah.
5 versions on your computer.
Oh yeah.
How do you know whether you need to install Python?
I don't know. So
In a command line, try typing Python 3, see if it recognizes that.
So when I started the installation file for Windows, it just kind of gives me this modify setup, which means that it's already installed. But I'm not sure which version it is. So I'm going to click on repair here just to see. And so now I know it's kind of updated.
And we want 3.9.5.
Yeah. I don't know if it matters, but peace of mind. There are no good Python IDEs. I use Spider. I hate it. Yeah. Yeah. That has an IDE.
Anaconda is like a monolithic package, so it takes care of it.
But it doesn't. So they were asking about an IDE, like a development environment. Well, exactly. This is the problem. So coders will tell you just use a notepad, just use your text editor, not having realized that you can. Well, there's so much more to a good editor.
I like VS Code.
Yeah. Okay.
You can run it right in there. You don't need to.
In academia, they get you hooked on MATLAB, and once you've had the MATLAB debugger, you never want to stop using it. Exactly, debug. All right, so I have installed Python. I shall close the Python tab and return to the Edge Impulse docs. The next one, Node.js. So I'm going to do not the current version, I'm going to do the recommended for most users version. I don't think we need the very latest. Oh, it should just be one file. I don't know why I got to there. Oh, so it was not Node.js that was so big. This was just 30 megabytes. It must have been the Edge Impulse itself. That makes more sense.
Try to do design craft.
Okay, here we go. All right, so I downloaded the Node.js file, and I'm running it. I think I've got this installed too, so let's see what it says. Yeah, so again, if you've already installed this, you're going to get this kind of change, repair, or remove thing. I'm going to just repair again, just to be sure. Does anyone know what Node.js is?
I don't know, it's a web server that runs JavaScript in your local machine that hosts web farm.
Well, NPM, what, oh yeah, I think of it.
NPM is a
Okay.
So the Node.js?
Node.js is a JavaScript web server that runs on your local host and allows you to write programs with web languages.
Oh, no.
So NPM is a JavaScript web program.
So it's all like this, all instead of running.
All right. When you install Python, if it's the first time at the end, there is an option to add to path. You should do that. That's my understanding. Otherwise, you have to do it later. And then we said that Node.js is runs web server on your machine.
Yeah.
Something like that. All right. Sounds good. Okay, Node.js is complete. So now we're going to do the Edge Impulse install. And so to do this, you need to open up your terminal, your Windows terminal, which is a weird thing these days. But if you just go to the search bar and type CMD, it's going to open up this old thing. When I was young, this was all we had. We lived in this kind of black little box. You could even play games in this little box. And then eventually you started typing Win, and Windows opened up, and you got all these windows, and everything was ruined. But this is good too. So I am going to pull up my instructions here, and I'm going to copy this little line next to Edge Impulse CLI. If we go back to this one, this is this line here. So you just copy that whole line, go to your command line, and just enter that and run. And it starts out saying, I sure hope you know what you're doing. Which I do not. I just took this line from the internet and put it into my computer. Yeah. All right, so that actually went very fast on my computer, but it says that it just updated 5 packages because I already did this on this machine. I think this can take significantly longer on your.
The first time I did it yesterday,
yeah.
it took about 5 minutes.
Oh, 5 minutes? All right, that's not too bad. Is it Sarah?
Huh?
Is it Sarah?
Yeah.
Yeah, Sarah. Sachi. Okay. So you two, are you doing this?
Yeah,
Yeah.
so
Okay.
she's up and running, you'll be up and running in 30 seconds.
Yeah.
Okay.
Working.
All right. Oh, okay, good. I will just continue here. So this should take about 5 minutes, apparently, this Edge Impulse installation. And then once that's done, you have the platform, the Edge Impulse kind of app, as it were, installed on your computer. It's not a traditional app in the sense of having a GUI. That's why it's called CLI, Command Line Interface. And so it's just a way to communicate with the Edge Impulse online interface, which is where you're going to do your interaction with the system.
Oh, so will we still load data through the browser, but then we'll just interact with it, like do things like with the model?
Yeah, it varies. Sometimes it's through the command line, sometimes, but mostly it's through the online system. Okay, so having done those two, I need to download the Arduino CLI and add to path. So to do that, I'm gonna go back here. So this is the docs page where we started. So we've done all the Edge Impulse CLI things, and now the second one is the Arduino CLI. Here is where we ran into trouble for the Macs yesterday. So doing it for Windows is straightforward. When you click on that Arduino CLI link, so when you're here, you click on the Arduino CLI link, you then click on the installation page, and here you have all the installations for Mac at the top, and then down here for Windows. It could be better done. So if you're in a Mac, you should be able to run brew update and then brew install Arduino CLI. My Mac was able to do this. Some Macs have been able to do this, but some Macs it doesn't work on. And those Macs were later having trouble with Chrome crashing. So I think so what we did was to just go down to this second installation option, and we did that, and that did work on those Macs, but we were later having trouble doing it that way. So I don't know if that's a good idea.
Yes, good. So now I have the Arduino CLI zip file.
Yeah.
And I just installed everything I've been doing under directed user owner.
Mhm.
So should I just extract that same directory?
Yep, that's a good way to do it. So the easiest way, if you're on Windows, is to just download this one probably. So you scroll down to latest packages, and you want to download the latest version of the Arduino CLI. Probably you have a 64-bit Windows system. All right. So you get this little zip file. Open it up. And then there's 2 ways to do this. So one is to just unzip it to the desktop, let's say we're going to be working on the desktop. You can just have your file there and use it there. But if you want to make that file available to you from anywhere in your system, you need to add it to path. So that's my Arduino CLI. If I want to add this to the path, Windows path. You know what? I'm going to switch around which screen I'm sharing because this is not working. Let me share this screen. There we go. Oh no, I should duplicate the screens. That's what I want to do. I need 2 screens. All right. Good. So, are you still seeing my screen? Everything's good? I'm going to assume everything's good. All right. So, if you want to add that file...
I can only see the screen that is showing like all of us on Google Meetings. I don't know if you...
Oh, yeah. No, that's that's fine. So, the way I'm going to add this Arduino CLI that I just downloaded from here to my path is I'm going to unzip it. I'm going to put it somewhere. I just put it on the desktop. And then I need to open up something called edit the environment, system environment variables. This is again where you need to be sure you know what you're doing. So you'd open it. You don't need to do this, but you'd open it up, edit environment variables, go to path.
Can I ask a question?
Yep.
So when I open the environment variables, I have user variables for owner and I have system variables. Would it be user variables for owner?
Yes. Yes, that should do it. And so I'm going to double click on path, and in path, I'm going to add a new environment variable. And then I need to go and find the file that I just unzipped. So in desktop, and I just dropped it into the desktop. It's right there. So, oh, but I don't want to add the desktop to path. That's a bit weird. All right, I'm going to drop this Arduino CLI into its own folder right here, and then I'm going to get the address or the directory location, and I'm going to make that the new system variable. So now everything that's in that directory will be available to me from the command line. So in the command line, when you run something, it's going to check, okay, is that file, if you're trying to run a file from the command line, is that file present in the current directory? If it's not, then it's going to go and check the path. Is it present in the path? That's what we just added. And if it's, it needs to be either present in the directory or in the path, otherwise you can't run the file. So the easiest thing is to kind of add everything to the same directory or to the path or both.
Mine asks me to give the path a name, like a variable name. I just called it Arduino-CLI. Do you think that's fine, or is it the same name?
No. So you find where you downloaded the file to. So the whole name of that folder. So C:/user/ my name in this case desktop TinyML. I take that whole thing.
Yeah.
Put it in the path. Okay. So where are we? Okay, so now we've done the first 4 here. And so the next thing is to install the Edge Impulse firmware on your Nano. So if we go back to the Edge Impulse documents here, we've now done all this. Well, if you were using a Mac here, now you don't really know what to do. Let's just stop on that a little bit. So, okay, so how do we do this for the Macs?
Mine was working and then
Hey, Chris, what's the unit command to change permissions? CH12. Change mod. Well, that's what's going on. Yeah, it is. Okay. Thank you.
Okay. So let's see if we have anything in the chat.
Yeah.
This is all CS.
Okay, fantastic, thank you. Yeah. Okay.
Literally, I would be the only one.
I don't understand.
Different seniors.
Yeah. And then it's
Like practice.
it's like we have one station.
Right.
Stanislav, are you using a Mac? Okay. Muted.
Yes, I'm using Mac. So.
Okay.
Oh,
So how did you? Oh, where did it go? Here we go. So which option would you recommend here? So some people, they just couldn't run brew update. They didn't recognize that. I don't know why. And then we used this instead, and that caused trouble.
It didn't recognize brew at all? Or?
Right. Or at least the command brew update didn't work.
Okay.
It would work. Yeah.
It worked on mine. I'll try now to figure out what are the maybe brew is not active or something. Give me a few minutes.
Yeah. So the question I had really is down here they have an option for Mac OS. Can they just use this? Because this one worked fine with Windows. So if they could just use this one.
Yeah, let's try. I mean, the only thing that I can say. Okay.
Okay.
So,
all right.
let's try with that.
Cool. So yeah, if you're on a Mac, did you try these? I have a Mac now, but it's working fine on that one, so I can't really. I don't know how much time I should spend on this.
Yeah, maybe
particular.
you can, I can work with some of the things that are not working upstairs, so you guys can continue on down here. How's that?
Yeah.
Hey, who's not working right now? What do you guys want to sort it out so that we can get a lot of instructions? All right, you guys can continue on. The tech support channel.
All right, good. So. All right. Now that we got rid of the Mac people, we can do some work. Oh no, there's still one. No. Mac's good. It's all good. Let's see now. So we now need to install the Edge Impulse firmware on our microcontroller. And so to do that, I'm going to go back to the installation instructions page and go down here. So where it says connect your development board, find your, oh, here we go, thank you. Find your development board and then realize that you are out of USB, no, here we go. All right.
What's up, pretty? You doing fine? Yeah. Does it feel funny? You know, like
I'm curious how it's awesome.
this is a little R&R for you.
Oh, R&R, it's just rest and relaxation.
Oh,
Yeah.
All right.
Yeah.
So I'm now going to try to install or update the firmware on this thing. Where is, oh, I got 2 Chrome windows open. That's why I'm having trouble. Here we go. All right, so to do that, you need to first double click on the little reset button, which is going to make the yellow LED start to kind of pulse. And that means that the microcontroller is in its bootloader mode. So firmware and bootloader just means that it's the code that runs closest to the core, kind of closest to the bare metal of the microcontroller, or at least as much as you can get to. So we're updating the firmware. We're updating all the instructions, the important instructions that go onto the microcontroller when we edit bootloader in bootloader mode. And so I am going to download here the latest Edge Impulse firmware. Open it up. Looks like this.
Can I see where you went to that Edge?
Yep.
It's under 2 update the firmware, the first.
Yes. So just down to 2 here, and here is just a single link. And then I'm going to unzip that to my TinyML folder. All right. And so there's a few different things here, but all we did today was, or right now was these 4 that ended up here. And so if my little yellow LED is still pulsing, I am just going to double click here. And this is where you find out if you did the previous installations properly. So we'll see. It should say something like finding Arduino embed core. And then it's going to start to mess with the
What command you ran to check it?
No, so just so when you the 4 files you download are kind of executables for Windows, Mac, and Linux, and so you just double click on the one for your system, the Windows one, Flash Windows, and that will then run the larger kind of the upload this firmware file. Oh wow! Okay, that was actually relatively quick. So this is what it looks like when it's set up. And so what I'm going to do now is just close this and go back to the instructions. It says here that once you've flashed it or clicked on the flash file for your operating system, you need to click the reset button to give it a chance to start over. And then,
do we need to do that?
so after you've finished flashing the system, you just need to press the reset button.
Right, so I was prompted to just run one of 2 commands or press any key to.
Oh yeah. So just press any key that will close down,
and then
click reset on the controller. Yeah. And then we're gonna open up the command window again. So CMD, command prompt. And then in here, we're going to write Edge Impulse daemon, or the daemon dash. So where daemon is, it's like an old term for a kind of semi-independent piece of code. There's a classic. What's it called? That's not. No, there's another one.
Where it's a thing that runs around the universe at fastest speed of light and moves every.
No. This is about a kind of genius developer who dies but leaves behind this software system that's kind of playing games with the people of the world and messing with them. And that's a daemon. Like it's a not quite an AI, just an independent system that can take certain inputs, do certain outputs. It's kind of autonomous in some sense. Anyway. Way too close to daemon. Why did I do that? So close. All right, so I'm going to hit enter. And now what this should do is to try to connect to my microcontroller. It's giving me 2 options here. And just to be extra sure, I'm going to go down to the search bar and type device manager. In the device manager, you can check what's connected to your computer or what's in your computer even.
You typed device manager in this command line?
Yeah. And so I'm going to open, that didn't help. All right. If you're not sure which COM port your controller is on, the easy way to check that.
I'm a little lost whenever you use this.
Yep. So I want to find out which COM. So when I run the Edge Impulse daemon, it wants to know which COM port am I going to use. And because I've got my microphone and web camera installed, it's got a few different COM ports to choose from. And so I'm going to just go to the ports here, disconnect it, see which one disappears. Number 4 disappeared. Reconnect it, make sure it's coming back. There it is. Okay, so this one's sitting on COM port 4. The COM ports on your computer are dynamic, so they're going to switch around, I think. At least that's my experience. And so you can't know necessarily just by knowing where you plugged it in. But now I know it's on 4, so I can do that again. So I just wanted to know which COM port I was on, so I went to the device manager. Just go in the search bar and start typing D, you get device manager. Open it up. Under ports, where you have your COM ports, I'm kind of just opening that up and then disconnecting and reconnecting my controller.
When I touch device dash manager, it says command not recognized.
No, in the search bar, yeah.
And then ports, right?
Yeah.
And if there's only one, we know that's.
Yeah, then you're probably fine.
What is it locating? I have a throw error when I do edge impulse gaming.
What's it locating?
Yeah, it's searching for something.
Just refer to edge impulse gaming.
Yeah.
Like all the files I'm supposed to have. Oh wait.
Oh, you mean when you actually run it?
Yeah.
Let's see. Yeah. So once you've got your port.
Do I have to run the command line from here? Okay.
So I got my port, I just hit enter, and it's going to start to.
So.
Why did it do that? All right, so what happened here was that my microcontroller, when I ran Edge Impulse, okay. So I ran the Edge Impulse daemon. It found the microcontroller. Because I'm already set up on this computer, it didn't ask me for my username or login at Edge Impulse, and so it just connected me to the project that had already been assigned to this particular controller, which was this responding to your voice tutorial. But I don't want to do that. I want to start from the beginning, and so what I'm going to do is to just close this. And they actually mentioned this here. So if you want to start from the beginning with a fresh project, you need to add the little append command -- clean at the end of your Edge Impulse daemon call. So I'm going to go to the command prompt again. And I'm going to type Edge Impulse daemon clean. Try again. When you do that, now it's going to ask you for your Edge Impulse username and password, which I hope everyone has. No. So I know I'm on COM port 4. Do that one. Right. And so this is what happens now. When you run the Edge Impulse daemon clean, it's going to ask you, after you've signed into Edge Impulse, which of your currently existing projects you want to connect this device to. You cannot just run the device, you cannot just run Edge Impulse daemon once and then use your microcontroller for any project. You need to attach it to an Edge Impulse project. And so I'm going to use this one, Axel, because we're going to do an acceleration.
And you were prompted this after running the -- clean?
Yep. Yeah.
Mine, even though I ran that, it seemed to connect back to the same projects that I had before.
So is it giving you an option to pick something, or?
No, it's just saying device Arduino is now connected to project, and the name of my project. I'll cancel it and try it one more time. See if I'm fine.
Even though you ran clean.
Is there something between daemon and clean? The command is just Edge Impulse.
It's clear now.
Oh, clear.
So I was also expecting clear, but that on the website here it said clean. I don't know. So try clear. It worked for me clean actually, so it should work. But the thing I'm realizing now is that this is the point where we need to step back and go into Edge Impulse and actually start to set up the project before we try to connect our microcontroller.
So mine did the same thing, but I think it would probably be fine. Like there's, as so long as I make my project or just do it under this title, it should be okay.
Is it possible that you only have one project?
Yes.
Then that's probably it. So the daemon is going to look for.
So Clear doesn't remove the projects, it just,
No, I don't think it's that. I think if you'd had two projects, it now would have asked you which one you wanted. But
Gotcha.
because you only have one project, it kind of goes straight to that one. I don't maybe.
I won't fix it now, but I'll just call it mine.
Well, so what we're going to do, I'm going to close this and instead go to Edge Impulse and create a new project. And let me stop for a second and just make sure everyone at home is following along. How is everyone on the call doing? Any questions? Slower? Any repeats? No? Okay, we're good. All right. So I need to share. Okay. So what I'm going to do now, so what we're going to do today, if we can, is to do a experiment. We're going to train a model that can classify different patterns of motion. What I'm hoping to get to at the end of the day is to have a little thing that if you move it in different ways, it's gonna make sounds or blink lights or something like that. We'll see how far we go. So what we want to do is to go to Edge Impulse. Let's take it from the very beginning here. So edgeimpulse.com should take you to your list of projects. No, it takes you here, right? Edgeimpulse.com is here, and then we're going to click on login. And if you already have an account, it'll take you straight into your projects menu. And so here I'm going to create a new project. I'm going to call it, what are we calling this? We are calling this TinyML Day 2, very creative. Good projects. Okay. So when this wizard comes up, I'm going to close it because I want to make sure we know what we're doing without a wizard. So this is what your project should look like when you start it. So it's kind of trying to help you along. You're supposed to follow all of these. You're supposed to follow this tool chain here, and once you're down to live classification and model testing, you should see that your neural network has been trained properly and it's working. It's able to be intelligent, and then after that, you can go into deployment and actually upload it to your microcontroller to run on its own there. One thing that I'm kind of slowly realizing with this is I've been trying to understand what this is for, because if I have even just a cable, I could pipe the data straight into my computer, which has a much more powerful AI and could do more. And I've been kind of stuck on that. But what this thing is actually for is, first of all, you're not going to train any models on the microcontroller. That's not its point. It's not trying to do that. That's why we have Edge Impulse. We want to train the AI, train the models in Edge Impulse using proper server farms. And then we want to upload something to the microcontroller that allows it to do something useful locally. So it's not even the accelerometer that's important on this thing, or the microphone. It's the fact that it's able to run AI systems at all. And so if you have a system trained that can do something interesting for you in the real world, this thing will do it right there on its own.
So
that's it. That's what it is. And so the input that we ultimately end up giving this thing could come in on one of the pins. They could come in through the serial port. Maybe the spiker box will do the kind of heavy lifting in terms of collecting the data, or there's some completely different system that we haven't even we can combine anything here. We can combine heart rate with time of day, with steps taken, with some bodily recording, galvanometer. I don't know. It could be anything. And the point is, can we give this thing rich data with labels, maybe just to classify different moods or different whether you're relaxed or agitated, or you could feed it voice and have it detect anger versus calm in a voice, say, and then this thing could sit on a coffee table, and if the conversation got heated, it could tell people to calm down
Or start playing
calm music.
Yeah.
Exactly, that sort of thing.
So, can I ask a question? So you mentioned yesterday that parallel computing is one of the things that has allowed AI to reach the point that it has now.
Yes.
So is that, now obviously I understand why that would be important in training the model, but is parallel computing also important in deployment?
Yes, it is.
Okay, so it's a parallel computing that it's maybe not the scale that allows for training, but it's a scale that allows for deployment easily.
So yes, but this board doesn't have any parallel computing on it. This one is just using a single core, and so it's going to struggle even to do the prediction, but it can do it. So that let's say the training is like 95% of the raw time that goes into
The actual use of the whole system.
Yeah. So the training takes a huge amount of time. What we call the inference takes a shorter amount of time, usually because you're only talking about, so with training, you may need to process tens of thousands of images. And then the inference is just classifying one new image. But that inference needs to happen in real time.
Yeah.
Otherwise it's no good. And it needs to happen on this microcontroller, whereas the image training can happen anywhere on server farms. So that's
So it seems like it's impressive in terms of how small it is.
Yeah.
And then also the fact that it has the processing speed to do sorts of these level of computations in real time.
Yes. So it can run artificial neural networks in real time if they are small. That's what it can do. And it can do that because it has a reasonably powerful processor and it has enough memory. I think it's 256, right? Yeah.
Yeah, this one, 256.
Yeah. All right.
What's a little uncomfortable to me though is that we are doing this offline training thing, and then eventually try to do online classification. So is there any extra steps that we should be taking care of, taking into account? We just assume that whatever works offline will work online as well.
Yeah. So we assume it works exactly the same way. Go on.
Yeah, so the whoever made the compiler for a microcontroller, they made sure that exactly same computation will happen in the cloud and on the microcontroller. So that's the whole point. So it's very hard, but they made sure that exactly same computation will happen in the cloud and on microcontroller. And the reason why we don't train on microcontroller is because of memory. So you cannot put whole training set in a microcontroller. You can barely put one image in a microcontroller. And surely you cannot put thousands of images on a microcontroller. So that's the point.
Yeah. All right. So let's see now if I go to devices in my new project. There's nothing here. What I'm going to do is go back to CMD, and then I'm going to do my edge impulse diamond clean. So now I'm going to need my username. Password, I'm going to assume I'm on the same COM port. Right. Oh, I have 4 projects ready here, including the TinyML Day 2 project. And so I'm going to pick that one. And now the Nano is going to get set up and kind of attached to that project.
Do you have a professional account for Edge Impulse?
No. No, this is just a standard.
I just asked that because when I was trying to add a new project, I ended up just deleting and creating a new one.
Right.
I didn't see an option to create one.
Oh,
So
yeah.
I was wondering if maybe there's like only pro accounts that will make more.
There is a limit. I mean, this is a commercial
Yeah.
software, but they give you kind of quite a lot of room to get started. At some point, I think if you want to do a lot of training, you have to start to pay them. But I think for our purposes, it's going to be enough. So what name do I want to give to this device? I want to call it Nano 33. And then it says, and then that's it. So it says at the bottom here, go to this address to start training your model. I'm just going to close this. And now that I'm back in the browser, I can see that the Arduino Nano is right there available and has a green light, meaning it's kind of currently connected. So my device is there. First step in the tool chain, successful. Next, I go to data acquisition. And so what I want to do here is click on, let's collect some data.
You did connect using WebUSB first, correct?
No, I didn't. and because of that, I'm not seeing the...
Yeah, connect using web USB. Try like that, and then it will offer.
But I wanted to avoid that.
No, please try like that, and it will offer you to collect data, I think.
No, but this will work for us. But the whole point of doing the full installation was to avoid this.
Okay.
So hang on. No, I don't want to browse dev boards. Oh yeah, okay. Web USB it is. Stanislav, setting up remote management API is going to be a pain, right?
Yeah, probably.
All right. Did you guys get help? Yeah?
Yes.
You're good?
I was, what was it telling me? Failed to sample or something like that, but
Yeah.
I'm restarting it and seeing.
Okay. All right. So I'm unsure why we just did all that then, but let's let's go back to Web USB and click on our microcontroller, and then this should open up. When this window opens up, you can be happy. So that means that you're connected via Web USB. So to use Web USB, you still need to upload the Edge Impulse firmware to the microcontroller. So that was good to step through. But yeah, I don't know if for this you actually needed to do the Edge Impulse CLI installation.
I think for the Edge Impulse CLI, you don't need to upload firmware. For the Arduino.
Oh, okay. But for Web USB you also do.
USB you do.
Yeah.
So these guys, I think all of these, the last three, we have the Edge CLI working on. There was, are the teachers having problems as well?
I don't know.
Let me check the chat.
I did 12
Stop presenting a sec. And then we're up here.
Okay. Hey, so, all right, we're working through this. What is is anyone remotely trying to install this stuff having problems? Airlay, I don't think has a kit yet. I'm going to sort that out.
How is this? Are you able to?
Hey, Chris, is this muted?
We can hear you, Greg.
Oh, you can hear me. I can hear you. I have a feeling this is kind of going to be the core issue for the for the success of this project. Because I think no matter so if we did it through Python, Stanislav, how do you?
I will try tomorrow to use that path because it's more flexible, and in my opinion, less installation will be necessary. So tomorrow, Yeah, I would like to install Arduino and optionally libraries for the board that should automatically install, and then use Python.
Because I was able to, yeah, so there were 3 students that had issues, but they were all the same issue. It was like one of the Node.js directories didn't have the right permissions, and I had to change mod on it, and it worked. But I'm just imagining what. I love open source software, but I also hate it, because it's kind of a pain. Yeah, so there's a trade-off, right? So it's a bit of a pain in the beginning to get this to work, but once it works, I think the GUI of Edge Impulse will be much better. So maybe we can figure out a way to.
The only problem for sorry for interrupting, for Edge Impulse, you will see now, it can record one continuous data. And if you have several labels inside that continuous data, you cannot really separate them.
This is on Edge Impulse?
Yeah, that's in Edge Impulse. So you have to hit record and record one small. So for example, for P300 or some EEG studies that we will be doing, you cannot really do the study.
All right, but maybe for some of the things, I think, for example, if you're doing EMG stuff, you could do something. Things that are more, yeah.
So I can explain later, but basically, if you record one big recording, so part of the recorded won't be useful. It will be just nothing, just the noise waiting for you to squeeze the hand or something like that. And you cannot really cut one portion of the file and trash it. You have to trash whole part of the file after that. So you have to trash everything from that point to the end. So it's a bit tricky with the editor.
All right, so it sounds like we're getting pretty good feedback, features, and we are aware of this. So we have to figure out a cleaner way to do the install. We've gotten some good feedback saying we have about 2 minutes of troubleshooting with students in the classroom. So maybe what we would have to do then is, I'm just reading more of the comments. Yeah, I suspect when we go to release this, we're going to have a cleaner install, or a very good thing where the teachers install it before the students get there. I mean, if this is on school things, then maybe we can work with the technicians. Okay, so this, yeah. So we should put a question out to the teachers, because I'm curious to see who installs the software, and then how do they, if you're doing something for a course that needed software, how do they get that installed? Because they're saying that they don't have permissions on their stuff. Okay.
One thing that I did notice, when we started CLI.
All right. Okay.
It's discussing port 4. Now we port 10.
I just read Ariel's comment. Students running over their laptops with the car. I can imagine that. My dad ran over his camera when we were kids. All right.
Every year this happens.
Yeah. Okay, so we have some people have IT departments that will do that. Some people have to go through this. Yeah, I'm just curious to see what a pain. We should come up with a survey to figure out what are the. Let's figure out the question. I want to know like how much we can expect schools to debug this.
But students in classrooms are going to be coding as Edge Impulse. Like, I think they're going to be using our configured microcontrollers to do science in the classroom. Program them.
I want them to learn. I mean, we could do it that way, but I actually really wanted them to learn to program. That's kind of that was the goal, because I think. Yeah. So I do. So maybe what. All right, now it makes sense. So I talked to Pete Warden last week, and he said that for educational stuff, he worked with SparkFun.
Yeah.
And SparkFun is selling the kits with the thing already installed, like the Arduino CLI thing installed. So that means
My label is left.
whatever step that was, you installed, that's gone. But you still have to install that CLI. But maybe that's a bit easier for schools to do. That way they don't have to sit with each device and do that one. Okay.
He used Bluetooth, I think, for the in order to connect. He said that.
Oh, that's right. Yeah. Okay. Yeah. So even better. He was saying,
said that,
right.
Yeah.
Yeah. He said that he flashes the like he has so we could do this, for example. When we send out our device, we can have it with a firmware on that has Bluetooth Low Energy, so that from the iPad or from the computer, they just connect that way. Yeah, you're right, Sensei. So now, all right, so it wasn't clear to me why that was so cool, but now I think.
Yeah, he said actually explicitly that they had a lot of problems with connecting through the USB.
Okay,
so
yes,
that's the same thing.
Yeah, so
Okay, so well, Pete's giving a talk next week, so he can probably explain this a bit more. But I think we've now, like, he was telling us this, but we didn't quite understand it, but now I think we do. So maybe, Stan, can you try installing that BLE thing? I'll try it as well over here, and then we can see if that.
The one that Pete proposed?
Yeah.
Yeah,
But that
it's
doesn't.
it's a website. Yeah, it's a website that's on Google.
Okay.
Created by Google, and they offer just one example, I think. So you
Okay.
cannot really do your stuff. You can just we can maybe make something like that that's more universal for our purposes.
Right. So we can. I mean, once we understand that BLE protocol, maybe we can do something similar. All right. Well, this is good feedback. So, all right, we agree. We have to sort this out. But that's why we're doing this. So we're gonna let's play with that BLE thing a little bit later on. But I think everyone here, if no one has them at home, I think we can continue on because I think all the students are ready. And then what we'll do is we'll do our homework and figure out the best way to make this a little bit simpler for everyone else.
are you good?
All right, Chris, let's just continue on. I think they're all set, and I think we have to figure out a better way to do this. You're right. Okay, so, all right, thank you guys.
All right. Okay, so we are going to assume that this was working for everyone, at least the people in the room and the people following along. And so what I want to do now in the last hour here before lunch is to try to get one full model trained on accelerometer data to detect different kinds of movements. And so what we're going to do is I'm going to take notes. Wait, I'm going to share first of all my screen. If I can find it. There we go. All right, I shall share my screen. And then I am going to return to Edge Impulse. So if I'm back here, what we found just now is that there are two ways to start to collect data. One is to just use the web USB system that we had before. If I click connect here, this comes up, and if I go back to devices, this is now green. So the fact that it goes red, I think it just goes offline if you leave it alone. But so now I'm back here, I click web USB, I click paired, and now this is ready to collect data. That's one way to do it. The other way to do it, because this didn't always happen for the people using a Mac, the other way to do it was to run the Edge Impulse daemon CLI, and then the Edge Impulse daemon in the command line, and at the very end of that Edge Impulse daemon, when you hook it up to a project, you will get a link that ends with something like training. You get an edgeimpulse.com link. It ends with something about training. If you follow that link, it's going to take you straight here with the record new data window open. So that's if you can't use the web the web USB, you can still run the Edge Impulse daemon if you set it up. At the end of the Edge Impulse daemon output, there will be a link. You take that link, copy it in here, and you should be good to go.
And that link is slightly different than what you would find just going through your browser.
Yes.
In that it doesn't attempt to use the web USB, it only attempts to use the common.
Yes, and it'll be specific for you, like custom created for you. So that's that. So now we're actually going to start creating, collecting some data. So what I want this thing to do now is to just be able to distinguish a few different motions. And so I'm going to start with, let's call it a window cleaner. I'm going to set the frequency here to 62.5. I don't know if that's important. I don't know if it matters. The instructions said to do that. And then I'm just going to click start sampling. So I wait for it to start. It still says waiting to start. Now it says sampling. So now it's actually recording data. And so I'm going to do this window cleaning motion. There.
And Chris, how long do you set that sampling frequency for? It seemed to be doing it for a long time.
Sampling length?
Yeah, is that? Oh, that's the length. That's not the frequency.
Yeah.
So that's
Yeah,
the number.
10 seconds.
So you did it for 10 seconds. I see.
Yeah, and I'm going to do that 10 times because the more data, the better. So now we are using continuous data collection, and let's come back and talk to why we need to use discrete words and gestures at some point, because continuous data collection is much easier. We don't need to mess around with windows and flanking bits that are noise and blah, blah, blah. Continuous data collection. It's not as efficient, but we're not starved for power right now, so I'm going to keep doing that for now. And then we can get into more advanced, like being able to identify individual gestures and stuff. But this is just a continuous motion. So I start again, wait, and sampling. All right, same thing. And so you can see here in the data output, the raw data output, that this is a, you know, there's logic there, there's order there. Green
Right. And so the idea is that you're going to the AI is going to try to figure out the similarities between all of these data sets, and it should find the feature of the green line going up and down. That's what we're trying to do.
Well, so we're gonna have that one, and we're gonna distinguish that from something else. Let's say we have one called snake. Start sampling the snake. And so now I'm gonna kind of move the. You can't see this because I'm sharing my screen, but I'm moving the.
Like a snake.
Yeah, it's very scary. All right, and so now you can see that.
I can see how AI would be able to detect these two, but
so you see the difference there. There's clear difference.
that's a snake. That's the
window cleaner.
wiper.
Yeah. And then this is snake. I'm gonna give it at least one more snake. Okay. Snaking. All right. Yeah, that one is tricky. Let's give it one more just to be sure. Let's do big snakes now. All right, so we have a bit more snake, and then I want one called Jedi. And you can guess, you can guess what that one's gonna do. Waiting to start. Yeah.
I like it.
Fighting. I am your father. All right. So now you can see that one quite different again from the previous ones. Let's give it one more. All right. Okay, so let's see if that's enough data. There's a pretty small data set there, just a minute, but why don't I go ahead, because you can add more data later, that's not a problem. So let's go ahead for now. I'm going to click on Impulse Design. And so here it's telling me, this is where you actually design the AI itself. They call it an impulse, and the impulse includes the pre-processing step as well as the AI. So the pre-processing step is where we extract the important features from the data. Again, you can't just look at raw data. You want to extract the key features so that the AI doesn't waste time looking at features that are not relevant to distinguishing the data. So that's what we're going to work out now. Fortunately, everything is kind of pre-processed or pre-set up with kind of probably appropriate settings, but we can always change that. So it's saying that we're going to use spectral analysis here, which is confusing because spectral analysis is typically what you use for kind of word detection.
That makes sense. There are a lot of oscillations in your data, so
yep. That's probably what yeah. No, it's true. And then it's going to use a very standard neural network.
So can we? So does everyone understand? Do all the teachers understand what that thing is? What we're doing right here?
Let's see. All right. If there are no questions.
How do you choose them?
I don't know. Let's see. We use a sliding window to go over the raw data. This is the size of the window in milliseconds. So is that same as batch size? No. That's the actual data size. Yeah, I don't know. But the thing is that we can adjust all of these, retrain the data, retrain the model, and see if it does better. And that's kind of one way, and otherwise just Google it, I think. But anyway, so spectral features, that was just telling us that what it's going to do is it's going to run something like a Fourier transform. It's going to extract the intensity of our signal at different frequencies. And then it's going to, so with the snake, for instance, that was moving back and forth at like a 1 hertz frequency. And so that's going to get picked up. Whereas the Jedi, I don't think had any clear frequencies because it was kind of more random, more stochastic. And so it's going to take those spectral features, run them in the neural network here, and then it's going to try to assign every piece of data into one of these 3 categories, Jedi, snake, or window cleaner. And I think it automatically adds a 4th kind of unknown category. I'm not sure. So I click Save Impulse, and then the little Create Impulse light is going to get green, and I'm also going to have these 2 additional impulse design options here. So you do need to click on these. So I've created the impulse, but then I need to go down and select Save Parameters here. There is a ton of information about these features here.
You got that from clicking Save Impulse?
Yes, I click Save Impulse, and here this will appear as an option. So I click on Spectral Features, and then I'm just going to scroll down on most of these, and just hit Save Parameters. But because at this point I don't want to mess with the settings necessarily. I just want to see if it works. If it doesn't work, we'll mess with the settings.
All right, so you have a 2-second window, and it's going to be shifting by 80 milliseconds. That gives you 700 windows per
right
in training set. Yeah.
Training set.
Okay, so we've generated the features.
Hey, that was pretty differentiable.
Yeah, this one shows us how well the categories are separated.
Dang, dude.
Yeah.
What do you think? What do people think? Is this if these dots were all black, could you figure out which cluster? Yeah, that looks pretty well clustered to me, Chris.
Yeah.
There's a couple greens in that orange, but
yeah, I think that's the beginning of the recording when everything is just still before she starts moving. So that's the part that's confusing.
Yeah, you're right.
Yep.
I'm actually quite impressed with that little data. Okay, and we haven't even done neural networks yet. That's just those three. That's the X, Y, and Z of 700 samples per.
700 examples.
Is that so? Was that it? Just merges it all together into one big thing, and then and that what it's doing?
Yeah. So each example is one dot, 1 point in that space.
But when he had that thing where it was like sliding by what was it, 70 milliseconds, wherever it was.
80. Yeah.
80 was that kind of concatenating all the samples together and then
yes, so it takes 2000 milliseconds window, so it just cuts from the data, then it calculates all the frequency analysis and everything, and it creates one feature vector, and that feature vector is 1 point actually, okay, in that space. Then it moves for 80 milliseconds, cuts the data from the original data, calculate again, put it information, everything. Yeah, okay.
But my question is, how many dots are on there? Is it 700 per snake, or is it 700 total?
I think total.
Yeah,
if you combine all the classes.
All right, and so that's just classic. You're just applying the feature. So now, pretty much any AI would be able to figure that out because it seemed pretty. Even like PCA would be able to do it, right?
Yeah, we can check what it plots. So I don't know what's the feature in that graph. That three features that
it was the spectral analysis of X, Y, and Z, right?
Yeah, but spectral analysis usually has like vector.
Yeah, but the features, you're right. Yeah, what is it?
One.
What do we know what that is then?
Where did the feature? Oh, here we go. Feature Explorer. This is the one.
Yeah, that's one right there. So what does that mean? Oh, RMS is what.
Yeah, that's RMS. Yeah.
I get you.
One of the features is just to take whole window and calculate RMS, and that's it.
So can you switch that? Can you drop it down from RMS? What else do they have there?
Oh yeah. Oof.
All right. So this is where you can actually see. But I think this is good. Whatever. Yeah, so as you choose different ones. So the idea is that if you can get little cluster, if the colors are separated, you have a better chance with your AI to be able to detect it. If the colors are mixed together, it's going to be, you can still do it, but it's going to be a weird. Yeah, just try it. Just what does that one look like? Yeah, see, this looks like crap, right? So you don't.
Pick 2, pick 3 there.
Yeah, so like an AI would have a hard time with him. So am I understanding this correctly that this software figures out the maximum?
But it what?
It seemed like the very first one you had was the most differentiated. Yeah, I mean this is just PCA. You're right, Jessica. Yeah. This is
yeah, it looks like it.
Well, it's not really PCA. It's like it.
It's RMS, just the. Power of the signal. So probably he moved his hands a bit stronger on one dimension when he was.
But just so everyone's clear, what we're trying to do, we when you're doing this stage, we want the different things to be kind of, or whatever we're trying to detect to be popping out from the rest of the dots, right? So. To me, I think this one's good, Chris. I think you'd be able to fairly
yeah. For sure. So now we go to neural network classifier. After we created the impulse, created the features, and so this is the actual brain that we're creating, and it's really so 33 features. That's the input layer. So that 33 features means 33 neurons in this case, each one responding to a single feature. And then we have two.
Do we know what those features are? Is the feature everything on that drop-down list?
Exactly.
I got you.
Right,
Okay.
right.
So it has RMS plus all those other weird things that we saw.
Right.
Yeah, big frequencies.
And there's 11 per axis. Okay.
Exactly.
Right. And so then we have two layers in the middle here with 20 neurons and then 10 neurons. And this is typical that you have kind of a funnel shape with a huge number of neurons at the top and fewer at the bottom. Not how the brain operates. Just saying.
And these are not spiking, yeah.
That they're not spiking. And so at the end here we have 3 layers. And so I'm just going to hit start training.
The 3 layers are Snake, Jedi,
and window cleaner.
Windshield wipers. Okay.
Yeah. All right. And so this takes a little time, although this should probably be quite quick because it's a small data set.
And this is the piece that we are paying for when you do it.
So are we paying?
No, you have a free version, but I think there's a limit to the 25 minutes of training.
Oh, 25 minutes, huh?
Per month.
We're going to talk about it, see if we can get a do that. I mean, like, to me, this.
Yeah, this bit can run on our computers. If we know what we want to do, we could set it up so that it's standalone. Yeah. But it takes time. A bit of a snake. Oh, cool. So here we have the performance then of the network. It's highly accurate, 96.5%.
Dang.
And then if I scroll down here and look at the feature explorer, so here the colors represent what the network thought the data point was. And so the red ones are mistakes. You can see they didn't make a mistake on the snake.
We knew that worked because we could see that at the beginning, right? That was the...
Right. And so anyway, so that's done, but it's not quite fully trained yet, so we may see some improvement. So once all this is done, I think you're supposed to retrain the model with known parameters. So now you do train model again, and I think this one is going to come out just a slight bit better.
Do we know what this is doing yet or not yet?
I don't know if this one is necessary. So this is, I think this is if you've changed some of the settings or you've added new data or something and you want to just come back and retrain, then this is what you use. So I don't know because we just trained the model. No, that's later in model testing. Because I just trained the model here, I think maybe retraining it here was unnecessary, and I just burned another minute of training time. But
yeah, so when you're retraining model, it starts from different random weights, so it may end up in a better position.
Oh, I see. So if you're not happy with your, did you go up or down in your retraining?
If you run in a local minima of the error, you can retrain.
I see. This is allows you to pop away.
So this one
you're
still
pretty good.
says
96.5. All right, so I get it. So that's
So now-
if you're not happy, you can retrain it again.
Yeah. And so now I can go to live classification here. And I'm going to go to web USB again. I have to do this every time apparently. Connect. No, wait, it's a problem if you're not using the web USB. I don't know.
All right, so yours seems to be working. We had some students that were not. So
Yeah. No, this seems to be working fine. Okay, so now I'm going to do a test to classify new data. The settings are the same as before. I'm going to start sampling. I'm going to do, I'm not telling you. Let's see which one this is.
That's a snake. Let's see if it knows.
I do not. Aren't I sharing my screen?
Yeah, I can see it. It's classifying it now.
Okay.
And what did it guess?
Yeah, so it's guessing
Snake,
absolutely right.
93%, yeah.
It's a snake at 93%. Okay.
No. So I think this is the number of instances. So
Okay.
It broke down. The
Oh, I see. So
percentage-
this is 10 seconds broken into windows. Is that what that is?
Yeah, broken into 93 windows. Oh no, broken
And
into
90
101 windows.
And then the uncertain one is probably that beginning stage again where we're not.
Yes, right. Oh no, actually, we can see here which one was uncertain. Or can we? So you can see. So all of the different segments of that 10-second recording are classified here individually. So you can see it's very sure that it's a snake most of the time. Still sure. Here it got a little bit, just a little bit confused.
This is amazing. Is anyone else impressed by this? I'm pretty impressed by this.
In the end, do you average?
Yeah, I'm waiting for Jedi because it's pretty random.
Yeah, the Jedi one was.
Well, let's try another one. So that one was fine. There we go. I don't understand how you're seeing me, Greg. What?
There's a little window there, man. We were pretty impressed with your Jedi. Yeah, everyone's impressed with your Jedi skills.
Aren't I sharing my screen? I don't understand.
Or with the AI, one or the other. I'm impressed with the Jedi skills.
Oh, you're seeing this one?
Yeah, we see you and the screen. It's all right, man. It looks good. All right.
Oh, I see. You can click on either one. I see.
Yeah, so you can see you. All right.
Okay.
You're off, though. They won't be able to see.
That's okay. All right. So this one got Jedi on 73,
That's still pretty good, man.
Snake on 11, and Uncertain on 17. So a little bit harder, but still definitely, on average, you got the right answer. If we scroll down here, we can see it's at the end for some reason that it.
Yeah, I think.
making-
Yeah, when you stopped, it
Yeah.
classified as a snake. So
Yeah, maybe I stopped too soon.
at the beginning and at the end.
All right. And now I'm gonna fuck with it. So doing a little snake here, but what's that? It says snake Jedi. Oh no! What's it gonna do? All right. Oh yeah, look at that. Snake Jedi, almost even split.
And the first half the time we move should be more.
Right.
snake than
And so
snake.
it begins with snake, and then suddenly the Jedi is broken in, and now it's all Jedi. So even within an individual time step, it can easily, switch and check what's going on in the moment. Excellent. Okay, so that's clearly working. We can go to model testing here and ask it to use data that is put aside to validate itself. So it's data that was not used for training, but was still from the original data set. So it's properly labeled, so it has the ground truth. And so you can use this to just validate your model and get a precise performance measure. No? Oh. Okay. Oh. Okay, I'm not sure exactly.
Maybe it's just using the same data that you
Yeah.
use for
So yeah, I'm confused by this one. So you have
Oh, so it was taking the live classification data.
Yeah,
It seems to be.
you can record
working that.
one more new file and try with that. Probably it will work then.
so this is the validation stage. Oh, I see. So then the live data is then you tell that if it was correct or not in the live classification, and then it uses that to validate.
No, you don't get an opportunity to tell it. I mean, here we just got to see, for each individual new data set how it was doing. But here it should have set aside 20% of the training data for testing, and I don't know.
Oh,
why
in the very beginning, it sets them aside. I see. That didn't make sense. Okay.
And maybe
Yeah,
Maybe.
when you are uploading data, you can select if it is for training or testing. So
Okay, check this out. So rebalance data set. This splits all your data.
It's the danger zone.
Oh yeah, let's do it. Rebalance data set. The data set was rebalanced.
And to remind me again, that's selecting samples for validation versus test versus training.
Yes. And so now that I did that, I can see here that on
now you have to
model,
retrain the model. Ah, that's why you use retrain model. I see.
so I think before it was using all of the training data for training and didn't set any aside, possibly. And so now it's gonna.
We should see it dropping a little bit, maybe in performance.
Yeah. And so it was trying to use the data that I collected during the live acquisition, but that data was unlabeled, so it wouldn't have been able to do any model testing with that data.
And look at now. So now we're at 80%, 79% versus the 96% when we have less data.
Oh, really? Huh.
All right, look what's going on here. It's going from floats to ints. That's one of the big compression points.
Yeah.
So a float is what? How many bits is that? 64.
it says float 32. It's
float 32. So from 32 bits to 8 bits. I guess I can just look at the number.
So look, so now we're down to 80% accuracy because we took out some of the data, and now even this here looks.
Yeah, we're starting to get a little.
Let's see. Yeah. But
so
let's try.
This is where adding more data helps then, increasing your testing set. Okay.
Okay, so what it did here, so because I rebalanced the data, now we have here 3 data sets that all have a known expected outcome. And they each, I think it needs an entire testing, like data acquisition set, and to set those aside entirely. And it didn't have that before. Now it has 4 of them here. So I'm going to go classify all.
And this should be lower than the other one because it's.
Yeah. Okay. We don't have enough data. I feel pretty. Yeah, this is terrible.
Yeah, I thought that was too good to be true. It just seemed like really, really good.
Okay, so maybe that was an example of overfitting. Like this is why we do the validation step. Is that good. So I'm going to collect some more data here. Back to data acquisition. Connect. And now.
Hey, I'm going to get on that chat thing. I want to talk to teachers. I have a feeling, at least for me, this is pretty intuitive about. But I have been reading about this stuff for a long time. But I'm wondering if the idea, if this user interface seems a little bit more user friendly than, I guess, what we were doing earlier today, which is trying to install software. But
we were trying to get to this point. We were trying to get the nano.
I get it. And I thought that was amazing that with that you only had basically 1 or 2 samples. But I guess it's not 1 or 2 samples because they divide it up into hundreds of samples.
But not independent samples. So I guess it was just 5 samples per, like 5 truly independent samples per recording, per 10-second recording, if it's using 2-second windows. So I'm just gonna.
Yeah. Okay. Yeah, I have a feeling too, Adam. I feel you on that one. So, but I think this is kind of the. It's one of the key features of AI is how do you make sure that your model's working? And so I think if we come up with some lessons around explaining the validation thing, yeah, I get that. That seems to be a that is a tricky thing.
Mm-hmm.
Yeah, maybe we should concentrate then on a convolutional neural network that doesn't have any pre-processing, just raw data into the network, and that's it. So,
no, but I think they're talking about the idea of the validation it's not intuitive why you need that, but it's maybe if you can explain it another way. So do people understand what we're doing with this validation step? Okay. Stan, you want to explain it one more time?
Yeah. So the actual validation is not something that I would explain to kids. So there is a training data, validation data, and a testing data. So during training, you are using one set of data to train the network. But in order to test the generalization of the network, you are doing validation all the time. Because you can overfit, you can learn to recognize training data very well, but your generalization will be poor. That's why you constantly test against the validation data during training. And if you see that error on validation data degrades, then you stop training. Even though if you continue training on a training data, you will be better and better and better, but your generalization is poor. That's why you use validation data. But the testing data is just used afterwards, so you can test how good your network generalized, what it will do on the new data. So in this case, it was not obvious why this was useful because Chris immediately tested it. So we had test data because Chris tested it. But if you record data off the site and then you come to the lab, then you need to have test data as a separate set. I hope I was.
Here it is. Yeah. So the way this is set up is that it allows you to collect training data and test data quite separately here, and so that's why I didn't have any test data last time. And instead of collecting more test data, I am simply going to go to the dashboard, scroll down, rebalance my data set, click yes.
Why is this such a bad thing? Why are they making it sound like you're deleting everything, reformatting your hard drive?
Yeah.
Is it because you have to retrain the network and that costs money? Is that what the danger is?
I think it's once you rebalance the data set, you can't get it back. Like it's going to shuffle it and set some data aside, and that's done. Like you can't.
Yeah.
And then you have to retrain everything.
Yeah, it will shuffle. So usually when you prepare training data, you make sure that you have all the use cases, all the edge cases in the training data, so that you have perfect set.
I see.
Then if you spend a lot of time on that, if you hit shuffle, then
I see what you're saying.
You have to do again because usually you will go in a loop.
So we were talking about this the other day. So what does everyone know what he means by edge cases? So like the idea with Tesla, like when the windshield wipers would come on when it rained, but every once in a while when you drive into a tunnel during a bright day, it looks like there's raindrops on there. And so the windshield wipers were coming on in the tunnels. And so in order to train the neural network not to do that, they had to pick a whole bunch of cases where it was driving the tunnels so that it wouldn't do that. And if you rebalanced it, it would kick on all those ones again and redo it again. So that makes sense now.
All right. Okay, so I noticed that there's a bad label that snuck into the data set here. So now it has 4 classes, including one called testing. No, that was not supposed to happen. So I'm going to go back to data acquisition. I'm going to find testing and kill it. So I'm just going to delete that one. Yes. All right.
Yeah, you can see in that drop-down menu that you can move it to test set. You saw that, yeah.
All right, yeah.
Oh, that's how you can move it.
Yeah, you don't rename it to test, but you just move it to test set.
All right.
And Adam's asking a question about visualizing. Is there a way to... The problem with neural networks, though, is how do you describe the data is being processed? At least I have a hard time visualizing it. I think kids need to be able to see it to understand what machine learning is doing. You know, I think maybe when we do the feature extractions from the when we start doing the convolutional neural networks with the camera stuff, I was able to understand that a bit better because you can visualize what's happening. At least I could visualize what was happening in those convolutional neural networks. So maybe in the next example we can do that.
50%. In free sample.
All right.
So you're
It's still a mess.
But not too much of a mess. I would say that's much better than last time. I'm going to guess that is 80%.
All right, let's find out. So, and then if it's not working, I'm curious, what if we add more neurons?
I'm going to call him.
Let's try. Let's after that check which one is most messy. My guess is Jedi because it's pretty random motion. I don't know.
Right. Yeah. But what do you mean massive?
Messy. Because I think the blue one intersect all other classes. Yeah.
Right. So the fact that it's breaking it up into 2-second windows means that there's going to be some where I was just not doing very much because I was in the middle of two like sword strikes or something. Anyway, so 89% accuracy on the test data, training data set. But if we go to testing and classify these, we get the kind of the real, sort of the real performance of the system, because it's when you're testing on the testing data, which is labeled, the computer is going to try to guess, and you're going to know exactly how well it's guessing. So here it guessed right 70% of the time. Pretty good. So before it was 20% last time. And then I added, I maybe tripled the amount of data, and now it's up to 70. But before I go on, first we want to see which one was most messy.
So one more trick with the accelerometer sensor is that you want to hold it the same way every time, okay? So, for example, board LED should be up, okay? Because if you turn around, then you are using completely different
but that's exactly the kind of thing I want the AI to be able to see and figure out.
Yeah, but you have to give it examples. So you have to repeat with a different orientation. And
but I was purposefully not holding the accelerometer the same way every time. So maybe that's part of the problem.
Yeah, so maybe you didn't give it enough examples when all the axes are.
Yeah, but let me try something before we give up on this data set. What if we add an extra layer? Ooh. Okay, I want a dense, fully connected layer. That sounds good. How many neurons does this layer have? It has 30 neurons. I think it should be up here. Okay, let's try that. So I just added an extra layer between the input layer and the two middle layers. And I'm going to start training now.
Yeah, my presumption is, the training will be better, but the generalization will be worse. So.
Oh, you think? Why?
Let's see.
Yeah.
Yeah. We can improve the performance of the network if we carefully prepare the training data. That's the main point. So you can really mess up if you don't prepare the training data well. So probably you just hold the sensor at some point, or you didn't present all the cases and those kind of stuff. So.
Yeah. Complete the. I mean, that looks very. No, it was. What was it last time? I forget. Let's see now. So if I go down to model testing and classify again.
Good.
Yeah.
But do you have example in a test set of Jedi? So did it completely ignore the Jedi?
Oh, you're right. You're right. Okay. Very good point. Okay, so the test data set did not include a Jedi. So I'm gonna specifically go into data acquisition here hit test data, and just add one Jedi or two. Let's add 2 Jedis. So it's all set up. Start fighting. Yeah. One more.
I respect the way it came out. It was the most incredible news.
All right. So I'm just going to actually go straight to model testing here and ask it to classify again. So we were at 73%, but it's absolutely true. It didn't have a single Jedi. I also see 2 data sets there called testing that probably shouldn't be there. Yeah, they shouldn't be there.
Yeah, just remove them, yeah.
Yeah. Okay, we're up to 80% anyway, so that's pretty good. There we go. Good.
I'm a Harry Potter fan guy.
Yeah, confusion matrix looks good. I think the window cleaner, if you repeat the movement with but you should hold the board the same way you did in training. That would be very good results.
What does window cleaner mean?
It was kind of just black.
Window, that was the window. Okay, I thought that was the AI thing. It was okay.
So it's actually similar to the snake, but it's kind of up rather than down. Not entirely the same, but sort of similar. Or flat rather than vertical.
We have a question. Says maybe I missed this, but what was an appropriate accuracy for validation? What would you say is a good cutoff?
For testing, validation is used during training. So let's forget about validation, but the testing. So in testing,
well, can we ask? Because they give you a percentage for both, right?
Yeah. So in testing, you expect to have accuracy that's a bit lower than in training. That's the point. So how well you have let's say 5%, 10%. That's okay. But how good your network will be in a training, that depends on a lot of stuff. So we will pick and choose examples that will give us good results in training, but people.
But what's a good like back at the envelope? It's like 80%. Like you want to.
Yeah, 80%. 80% is perfect. So,
okay.
But you know, the AI community is constantly trying to solve a bunch of problems, and there are some benchmark problems on which they compete, and it's a 60%, 65%, or something like that. So, but if we have something like 80, then you have useful. Yeah.
Yeah, and so is uncertain included as one of the? Because someone's asking what is chance. So is 33% chance or is it 25%? Is uncertain the real category?
Uncertain, it's not category. Yeah, it's separate category. So everything else.
So chance would be 25%.
No, I think so. The network wants to assign every new data input to one of the 3 categories, and if it's below some threshold on all of them, it's going to go to uncertain.
I see.
Basically,
so it's 25%. Okay.
Yeah. Okay, so that's looking. Let's say that's good enough for now. So what I think we could do is to break for lunch here, and then when we come back, we're going to go to the deployment section and actually create the Arduino code.
Yeah, cool. Then
that we will need to upload this, and then once we've uploaded it, if there's time, we're going to just edit that Arduino code a little bit to allow you to output the 3 different categories as a tone or an LED or something kind of turning on, just as in a hello world.
That's perfect, man. I mean, I like this Edge Impulse software. I think we have to get through the install bit, which we can. Then we can also take a look at what Pete Warden's using. He's got a different tool as well. So I mean, I think part of this process of the summer is finding the right tools to use that look intuitive. But this, to me, seems useful enough. If you understood the concepts, I mean, the hard part was getting the concepts down. But I think if you understood the concepts, the way they've kind of laid it out seems pretty good to me.
Yeah, it's good. It's good. It gives you everything you should be aware of. I don't know how it does with importing data. I think that's what we're gonna.
Yeah, that's where it's gonna get. And that's what Stanislav was saying earlier.
Yeah.
That when you start collecting your own data, it may not be as good.
Yeah.
But maybe that's something that we could come up with, some type of script. And then, okay.
Yeah. All right. So what's the schedule now?
We don't really have a schedule. I was going to be open for the afternoon to work on projects, but if we could ask people, would they rather come back today or start again tomorrow morning, or because what's left now is that Chris has a model that seems to work in the software, and so the question is, can you actually stick it on the hardware and then do it and then have it detect snake, windshield wiper, or yeah. So.
Yeah. So we can certainly get that up and running here. Starting at 1 and just work through the afternoon.
All right. Yeah. Well, maybe just break for come back at 1 o'clock. All right. Perfect. Thank you, guys. This is awesome.
Thanks, Greg.
Thank you.
Thank you.
Thanks a lot.